Hey everybody. Transformative change takes a lot of time. For example, HL7 FHIR came along in 2011, and now 14 years later, that transition is still underway. USDM is a great idea. It can revolutionize the way that clinical trials are designed and conducted. But realistically, that transition is also going to take years, maybe a decade or longer. But what if, magically, all legacy protocols, new and old, could be instantly transformed into perfect USDM without waiting for adoption by hundreds of separate organizations? Then USDM could be used for communication and implementation right away. I'm Mark Kramer from MITRE, a U.S. not-for-profit corporation working in the public interest, and I'm going to tell you how you could vastly accelerate USDM adoption. I've been a major contributor to health data standards for more than 15 years, a software developer for more than 20, and an AI researcher cited over 12,000 times in the literature. And I've brought all that experience into play to develop Protocol Miner. Before we dive in, I want to talk about generative AI. Using AI, you can take any protocol and ask for something like inclusion criteria and get accurate results nearly 100% of the time. But when you ask about schedule of activities, more often than not, those answers will be wrong. Part of the problem is tables. AI doesn't see complex tables correctly. In fact, this is a problem across multiple tools and even AI systems specifically trained on tables. And none of these tools are equipped to handle tables that extend across multiple pages. Of course, it's not just getting the structure right, it's understanding the nuances of the content. For example, this column, cycle 2 and beyond. Here it says cycles are 21 days, so everything in that column must happen every 3 weeks. Except, this first procedure is only going to happen in cycle 2 and then never again. The next item is only going to happen if necessary, and the last 3 items are only going to happen every 6 weeks or 9 weeks or 12 weeks, depending on where you are in the cycle. It's actually quite tricky. Protocol Miner is a non-commercial, freely available web-based application. You sign up and supply your own API keys for OpenAI, Gemini, or Claude. It's very simple to use. First, you upload the PDF of your protocol, or just specify the NCT number. Or you can have Protocol Miner pick an NCT randomly for you if you just like to experiment. Next, you supply the page numbers where the SOA tables are located, as well as the associated footnotes and abbreviations. Then you start the analysis. Now, Protocol Miner is going to go through several phases, and the process will take a few minutes. The first phase involves having the AI read the entire document and determine information such as the study arms, inclusion and exclusion criteria, and more. A lot more could have been done here, but the focus of this app is the SOA. So this is more or less a placeholder for extracting all the information with the exception of the SOA. Now, the app now extracts the SOA tables page by page. We worked very hard to get this precisely right because the last thing you want is to miss a time point or an activity. The app creates and outputs an Excel file that are visual twins of the source tables. I'm cross-fading these files so you can see how precisely they're matched to the originals. In this case, the SOA is split between 3 pages, so the next step is to combine these into a single large table. The application is capable of stitching together multiple subtables, whether they're split horizontally or vertically. Now comes the fun part. It's where timelines are generated by enumerating the time points in the header and placing them in chronological order. Protocol Miner accounts for many factors at this stage, including repeated cycles and time windows. We also account for columns in the SOA table that expand into more than one visitor encounter. The result looks something like this. It's a table listing each timeline event. The timing of each event is relative to a fixed anchor or another event, with a nominal start time and optional time window. Repeated events have a repeat window and a stop condition extracted from the text. To help envision this, we produce a graphical view of the timelines shown here. Each visit is indicated by a bar with whiskers indicating the time windows. I'll mention that there can be more than one timeline, for example, a separate timeline for early termination of treatment. The next major task is determining the timing of procedures within each visit. This analysis is similar to that of the main timeline, where procedures within a visit are put in order relative to each other. Often the ordering is known, but the duration is not, so the x-axis here should not be interpreted literally, but more in terms of what precedes what other procedure. So the final stage, where we produce the actual USDM and FHIR, it's visually the least interesting, but of course that's where the rubber meets the road. Here is the USDM JSON, and here is the FHIR shorthand, also available as JSON. Finally, all the reasoning behind all these steps are available for inspection and confirmation. And we've evaluated Protocol Miner on 30 varied protocols, resulting in very high accuracy, verging on 100% across the board. So in conclusion, how can you accelerate USDM adoption? By using Protocol Miner to create USDM from any legacy protocol, not by waiting for adoption from hundreds of separate organizations. Only Protocol Miner tackles the central problem of the schedule of activities, allowing these protocols to be implemented by multiple organizations in a standard way. Thank you very much.